Alright, in today's video we're going to take a closer look at some vocabulary from our earlier class. Specifically, we're going to delve into the idea of isotopes, and we're going to try to figure out how many protons, neutrons, electrons are in a given isotope. So just some quick review. If you don't know this, you'll want to take this down as some notes for yourself. So we defined the atomic number in class. We said it was the number of protons that are in the nucleus of the atom. So every atom has a unique number of protons, and the periodic table arranges the elements in order of increasing atomic numbers, or increasing number of protons. When you look at a periodic table, you'll see hydrogen has the atomic number 1, so every single hydrogen atom has 1 proton at its center. If you look at the element carbon, you'll see an atomic number of 6 on the periodic table, so therefore every carbon atom has 6 protons in the nucleus. The atomic number identifies the element that you're dealing with. The symbol for atomic number is a capital letter Z. Now, if an atom is neutral, and atoms are not always neutral, but if you're told that the atom is neutral, then it has to have the same number of positive protons as it would negative electrons. So that the atomic number can also tell you the number of electrons around the nucleus, again, only if the atom is neutral. If you're asked to define atomic number, you should say it's the number of protons in the nucleus of the atom. The second important term is mass number, is given the symbol capital A. And this one is defined as the number of protons and neutrons in the nucleus. Now, those are the only particles in the nucleus, and they're sometimes referred to together as nucleons. So you could say the number of nucleons in the nucleus of an atom, but most people would say the number of protons and neutrons together. Now, if you recall, the proton and the neutron each has an atomic mass of 1 atomic mass unit, while electrons are almost massless. So when we are counting how many protons and neutrons are in the nucleus, we're essentially counting almost all the particles that give the atom its mass. Therefore, it's called the mass number. Both the mass number and atomic number are counting numbers. So you're counting 1, 2, 3, 4 protons, etc., or 1, 2, 3, 4, 5 protons and neutrons. So they will always be whole numbers or natural numbers from 1 upwards. Okay? They'll never be decimals. Next comes the definition of isotopes. Every single atom of hydrogen has 1 proton. That's what makes it hydrogen. Its atomic number was 1. But different atoms of hydrogen could have different numbers of neutrons. They could have different mass numbers. So isotopes are atoms of the same element. Now you could also say atoms with the same number of protons. That would mean the same thing. That have different numbers of neutrons. So different numbers of neutrons. Alternatively, you could say they have different mass numbers. A simple example of that, carbon-14. When you see something written like that, carbon-14, that number 14 is the mass number. Okay, the mass number for this isotope. So you're saying, I'm talking about a carbon atom that has a mass number of 14. So 14 protons and neutrons. And finally, there's something called the atomic mass, or more precisely, the average atomic mass of the atom. And it's exactly what you would think it is. If you were to somehow find the mass of an atom, if you imagined having an electronic balance where you could measure the mass of an atom, the atomic mass is what you'd be determining. So it can be measured in grams, or more commonly in this unit, we're going to use the units atomic mass units, just because they're more convenient when you're talking about the mass of little tiny particles like atoms or protons and neutrons. Now let's see if we understand what we just talked about. Here we have 2 different isotopes of sodium. The nucleus of the atom is at the center, and then it's been magnified so you can see the nucleus here. In this atom on the left, you can see the symbol underneath is Na, sodium's element symbol, and then at the top left is the number 23. That number 23, you should probably write this down if you don't have it somewhere in your notes. That number 23 is the mass number. Underneath it, the number 11 is the atomic number. Okay, now the atomic number is found on the periodic table, but a mass number is not, right? There can be different isotopes of sodium. Each one has a different mass number, so you won't find mass numbers listed on the periodic table. Because the atomic number is on the periodic table, the number 11 is with sodium, sometimes the symbol would simply be written 23 Na, and they would not show the atomic number because you could just look on a periodic table to find that. Now, in this particular isotope of sodium, we know since the atomic number is 11 that it must have 11 protons. We know that the mass number is 23. So together with the neutrons, there are 23 protons and neutrons combined. But there's already 11 protons. So if you take 23, the total number of protons and neutrons, and subtract 11, so 23 protons and neutrons, and subtract 11 protons, you're going to find that there are 12 neutrons. Right? So notice if you take the mass number and subtract the atomic number, you get the number of neutrons. In this case, 12 neutrons are in the nucleus of this isotope. We assume it's a neutral atom, so the number of electrons orbiting that nucleus would also be 11. They have to be equal to the number of protons. Each electron has a negative charge, each proton has a positive charge, and they'll be equal, so they cancel each other out, and the atom is neutral. On the right-hand side, we have another isotope of sodium. This time it's sodium-24. Notice how you'd write the names of these things. The one on the left would be sodium-23. The one on the right is sodium-24 because its mass number is 24. Now the difference between the two isotopes, sodium-24 has one more neutron. Right? So there are still 11 protons because it's sodium. Every atom of sodium has an atomic number of 11. Because the mass number is 24, the number of neutrons must be 13. 13 plus 11 gives me the 24 as the mass number. All right, so these two isotopes of sodium, they each have 11 protons. They each have 11 electrons because they're neutral. But they differ in their numbers of neutrons. Sodium-24 has one extra neutron and therefore is a little bit heavier than sodium-23. See if you can pause the video and answer these questions. In addition to telling me how many protons, electrons, and neutrons, why don't you also identify for each one the mass number, so the mass number, and the atomic number. So identify how many protons, how many electrons, how many neutrons, identify the mass number and the atomic number. In the first example, phosphorus 32. In the second one, potassium 39. To help you out, I've put in the video here the elements as you'd see them on our periodic table if you were to look them up. So pause the video and try to answer both of those two questions. So for the one on the left, we can tell that the mass number had to be 32 because the name given was phosphorus 32. From the periodic table, I can see the atomic number, which is the whole number, number 15. And so because the atomic number is 15, there has to be 15 protons. That's what the atomic number tells me, how many protons there are. Because it's a neutral atom, there would have to also be 15 electrons. The protons are positive, the electrons are negative, and so they'll always be equal. The neutrons are neutral, the neutrons, and how many of those will there be? Well, the 32, the mass number, is the protons plus neutrons together. The 15 is the atomic number, it's just the protons. So notice if you subtract those two things, you're going to find n, the number of neutrons. So 32 take away 15 gives me 17 neutrons. On the right, we have potassium 39. Its mass number given in the question is number 39. Its atomic number is right there on the periodic table. It's number 19. Because the atomic number is 19, it must have 19 protons. Because it's neutral, it will have the same number of electrons. And finally, if it had 39 protons and neutrons, the mass number, and it's got 19 protons, subtracting those two things will tell me n, the number of neutrons, and in this case we're going to get 20 neutrons are in that isotope of potassium, okay, potassium 39. All right, so that should give you enough information to jump in and try one of the assignments that are on Google Classroom. The assignment there involves filling in a table where you basically have to do this, what we've just done here. Tell me the mass number, the atomic number, protons, electrons, neutrons, etc. in different isotopes. So good luck, give that a try.